Welcome everyone, video lesson number 11, Mr. Pasco here on percent of a number. Today's question of the day says, how is finding the percent of a number similar to finding equivalent ratios? I think that what you're going to see is you are going to see similar strategies used in the past with equivalent ratios. We're going to be using those same strategies to find the percent of a specific number. Let's go ahead and get started. Use 3 different ways to determine the percent of each number. We only have one example here, 10% of 85. So if you were to examine that small little question right here, 10% of 85, our answer isn't going to be greater than 85 because that would be over 100%. We want to find 10% of 85. So our answer will be much less than the number 85. Just keep that in mind. We want to figure out the part, in fact, 10% of the whole, which is 85. One way to determine our answer is by investigating this word of. 10% of 85. I know that 10%, when you move the decimal, becomes 0.1 or 0.10, 10 hundredths or 1/10. So the word of for me means multiply. So I can multiply 85 times 0.1. When I do that, 1 times 85 is 85, but I have one decimal spot that I have to move from right to left. So 10% of 85 is 8 5/10. Let's continue with our second way. A little more visual here. I like to use a double number line in this case. So I set up our double number line so that we have the percent on top and the number down below. We know that 0% of any number is 0. We know based on this question that 100% of our number is 85, so they correspond to each other. We need to figure out 10%. So we need to figure out 10% of 85. Can anyone tell me how we can find that number? Well, we can use the idea of equivalent ratios. Divide by 10 to both the top and the bottom. Because 100 divided by 10 is 10. 85 divided by 10, again, is 8.5. So 10% of 85, there it is 8.5. The last way here is a way that I introduced to you just a little bit last lesson. I wrote down that the percent over 100 is equal to part over whole. Please make sure that you have that. Percent over 100 is equal to part over whole. We're going to use this to fill in some information that we know. So we know that 10%, which is what we have, over 100, which is the whole, essentially, is equal to, now we have the part and the whole. In our question given here, 10% of 85, are we given the part or the whole? So does 85 represent the part or the whole? I think that you should all know and you should all recognize that 85 represents the whole. We need to figure out the part. Now, I can't think of a factor of 100 times something that will give us 85. So again, what we have to do and what we've been doing in the past is break down a fraction so that we can build it back up. So 10 over 100, 10%, is also 1 over 10. So they reduce. So 1/10 is equal to something over 85. Now, can anyone tell me the factor between 10 and 85? Well, 10 times 8.5 is 85. 1 times 8.5 is 8.5. So there it is. I'll be honest, the way that I use the most by the end of this unit is probably method number 3. Number 2 is a great visual way to represent percent of a number. Number 3 is a little bit more computational, a little more abstract. So being able to break down your percent, like I did here, in order to build it back up, that's a great way to find equivalent ratios. One thing that I want you to keep in mind is the idea of equivalent ratios. I wrote that 10 to 8.5 and 100 to 85, those are equivalent ratios. Recognize that we have the percents on the left and the number on the right. Kind of interesting. Let's move to example number 1. Example number 1 says there are 40 boys on the modified swim team and only 12 of them are in 7th grade. Find the percentage of 7th graders on the swim team. I want to show us 2 different ways here, methods 2 and 3 from above. I'm going to use a double number line to start, and then I'm going to use the idea of 2 fractions setting equal to each other as our second method. So let's go ahead and get started. So I set up the double number line so that boys are on top and percents are on bottom. I know that 0 boys represent 0% of the swim team. In this case, we need to find the percent. We know that there are a total of 40 boys. That represents 100% of all of the athletes on the team. We know that out of those 40 total boys, 12 of them are 7th graders. We want to find out that percentage. Now, just like we've done in the past, I can't think of a number. 40 divided by it will give us 12. So what we have to do is we have to break down our number 40 to build it back up. What do I mean here? I see that if I do 40 divided by 10, I end up getting 4. In order to keep equivalent ratios, 100 divided by 10 will give us 10%. So 10% of all the boys represents 4 boys. Now, I think that you can see it now. 4 times 3 is 12. 10 times 3 is 30%. So 30% of all the boys on the swim team are 7th graders. Method number 2, we're going to set 2 fractions set equal to each other so that percent over 100 is equal to part over whole. Let's fill in some of the information that we know. Well, first things first, we do not know the percentage, the numerator that's going to go on top. So what we can do is we can just have the denominator of 100. We do know the part. We know that 12 is our part out of the whole, which is 40. Now, I can't think of a number of 100 divided by something will give us 40, or 40 times something will give us 100. So what I can do is I can break down the fraction of 12/40. So we'll keep our fractions equal to each other. I can divide both the top and bottom by 4. So that becomes 3/10 here. I know that 10 times 10 is 100. 3 times 10 is 30. And there it is again. 30% is our answer. I wrote 30% of all the boys on the swim team are 7th graders. I also just identified 3 equivalent ratios in red here. 4 to 10, 12 to 30, and 40 to 100 are all equivalent ratios. I was able to find those equivalent ratios right on our double number line, a nice visual representation of how percentages relate to equivalent ratios. Example number 2. The hockey team won 60% of the games this season. If the team won 15 games, how many games did they play? So first things first, a double number line, percents on top, games down below. We know that 0% of the games is 0 games. We know that the hockey team won 60%, which is also 15. So we know that 60% on top is 15. How many games did they play? So again, this is one of those problems that if we break down our ratio, 60 to 15, we're able to build it back up. What I see is if we divide 60 by 3, that'll get us to 20%. If I do 15 divided by 3, that will give us 5 games. So I know that 20% of all of the games represent 5 games. Now, in order to get to 100%, which is how many games they played in total, I have to do 20 times 5. Whatever you do to the top, you have to do to the bottom. 5 times 5 represents 25. So 100% of their games represents 25 games. The second way, we're going to set those two fractions set equal to each other. Percent over 100 is equal to part over whole. So we know that 60 over 100, that's going to be our left fraction. Now we have the fraction part over whole. And we know that the number 15 right above here, 15 games, that represents how many games they won. So that's just the part 15, because the total number of games would be the wins and losses. So let's go ahead and get started. Let's try to make equivalent ratios. I see that 60 divided by 4 is equal to 15. 100 divided by 4 is 25. So their whole games, the question says, how many games did they play? We know that the hockey team played 25 games. Just a side note from our double number line, we know that 20 to 5, 60 to 15, and 100 to 25, those are known as equivalent ratios. So there it is. I hope that you're able to recognize the similarities and the relationship between percentages and equivalent ratios. Have a great day. Thank you.